For the final exam, what you need to study is basically the pre-lab questions and the data sheet. Like if you have additional questions in the data sheet, you want to be able to do some simple like calculations related to each of the experiments. Like for experiment 1, when you did like measurements, there were like 2 concerns. One, which was a question on the pre-lab as well, it was talking about finding out how many significant figures a given number had, and also if you were adding or subtracting 2 numbers or multiplying 2 numbers, what would be the recorded or reported number based on the number of significant figures that is allowed. So first of all, be able to count the significant figures, and then when you are doing addition or multiplication or any math, what to report, okay? So it would, you know, you have to indicate what is going to, how many significant figure is allowed on the reported number, and you need to round it up to that many number of significant figures. Like for experiment 2, you calculate the density, you measured mass, you measured the volume, and you calculate density. You had an example in the pre-lab, you did the calculation for the liquid and for solid, you measure the mass and the volume. So if you have a problem that gives you a question that gives you the mass and the volume, you should be able to calculate density. If it's given density and volume, you should be able to calculate the mass. So it's not, the questions are kind of expected questions, what you have from already, you have seen those questions, or you heard me talking about during the pre-lab discussions. So make sure to prepare for the exam, you go back and look at the questions. You already have the access to those questions, and make sure that you know the answers to those questions in the pre-lab. And then if there's additional questions in the data sheet. So then you had the next experiment, you had a calorimetry experiment. If the temperature of the reaction mixture, like if you have a reaction, if the temperature goes up by 10 degrees Celsius and you have the mass of the container, how much heat has been released. So how much heat you have to add to, let's say, 10 grams of a compound to increase the temperature by 5 degrees Celsius. So the formula that you were using there was Q equals mass times specific heat times change in temperature. Those are like 4 different variables. Any one that is not given, you should be able to calculate that if the other 3 is given. Then we talked about like organic compounds. This was more of calculating, determining density and melting point or boiling point of the sample, like general property. Organic compounds, they have lower melting point compared to ionic compounds, and they are not soluble in water. Just have like have a general idea. The best thing would be to go back, watch the video, or read the experiments, or do both to be prepared for the exam. Then you have this experiment that is reactions of copper. For the reactions of copper, you have multiple steps of the reaction. And then with those multiple steps, you were able to like indicate what type of reaction is. Is it like a combustion reaction? Is it like a combination reactions? What type of reactions do you have? And let's say when you add sodium hydroxide, what will happen to like after you add nitric acid to the copper, you dissolve the copper in nitric acid, you get copper nitrate, then you add sodium hydroxide, you get like a blue color precipitate. And then when you heat it up, it changes like black color precipitate. So I don't want you to memorize all the steps, but if I give a chemical reaction and regarding that experiment and say, you have a mixture of solid and liquid. In this case, when you filter it, which one would be filtered out? And I also want to let you know that the questions are all multiple choice or true false reactions. So for example, what happens in that? What happens for the reaction of copper? What happens if you don't dry the copper completely? Would you get higher percent recovery, lower percent recovery, or what would be the situation if you don't dry the copper completely? So when you are trying to precipitate copper, if you add sodium hydroxide to precipitate copper, what happens if you don't add enough sodium hydroxide to precipitate the copper? Of course, some of the copper would stay in the solution, and then you are going to decant it, so you lose some of the copper. So basically, understanding that, that experiment. This organic reaction, which is, I think was like experiment 6 for the organic reactions. If I give you a test, okay, test result, and I say, for example, this unknown compound had positive tests with DNP, or 2,4-dinitrophenylhydrazine, or positive DNP, and it was like negative or positive with iodoform. I will give only one of the cases, not both. It's not either or, it's either negative or positive. And if it gives like a positive tolerant test, what is this compound? Is this water? Is this aldehyde? Is this ketone? So a positive tolerant test, we know that DNP, if it's positive, we know is either aldehyde or ketone. And if the tolerant test is positive, then we know we have aldehyde. So based on the results of the reaction that you have, you should be able to indicate if your reaction was ketone or if it was aldehyde or it was water. So make sure that specific reaction, about ketone, aldehyde, and the water or methyl ketone, make sure that you know what are the test results. I will not do that with experiment 13, okay? Because the test results, it requires a lot more memorization and you're just doing it today. But I could give you questions based on the result of the experiments that shows either is aldehyde ketone or methyl ketone. So make sure to get that part. So then carbohydrates, remember the pre-lab questions, it was asking if the compound is a disaccharides or if it's a monosaccharides. And then if you have a test that it would like give positive Benedict test or positive Molish test, and what would be the unknown? Like, would that be glucose? Would that be fructose? What would be that unknown? And to find out if you're given a compound, is it polysaccharides or disaccharides? Then next one, gas laws. We had two gas laws. One was Boyle's law, the other one was Gay-Lussac law. In the Boyle's law, if you increase the volume, pressure goes down. If you decrease the volume, pressure goes up. The pressure and volume, they are inversely proportional. And then for Gay-Lussac law, if you increase the temperature, pressure would go up. So just have general idea about those two gas laws. And know that which one shows relationship between pressure and temperature, and which law shows the relationship between volume and pressure. Solubility, what is general trend in solubility? The higher the temperature, the higher the solubility. The other fact that you need to know, like dissolves in like. So if the solubility, for example, is 30 grams per 100 milliliter of water at 50 degrees Celsius, what does it mean? It means that you can dissolve 50 grams or 30 grams at 50 degrees Celsius in 100 milliliters of water. Just to understand it. At lower temperature, then some of that compound that was dissolved, it will come out. That is known as crystallization or precipitation. It will come out because it gets, it's a saturated solution. And if you lower the temperature, you can crystallize some of the sample. Making solution is the formula that you use, M1V1 equals M2V2, or C1V1 equals C2V2. That is dilution, is used for dilution. So if you have a solution that is concentrated, you can add water to make dilute solution. You're using that formula for calculation. Electrolyte is, so for making solution, you had like 4 problems as a pre-lab. And I asked you just to do those 4 problems, to solve the problems. And for the data sheet was the same also. And you didn't complete that table. So the only part that you'd be responsible is like sample problem. Maybe just know how to make like 5% solution or something. Just within that same page. I'm not bringing additional questions from outside. For electrolytes, 2 conditions for electrolytes. It has to be met. 1, it must be ionic. 2, it must be mobile. So NaCl is ionic, and if it's solid, it would be non-electrolyte, but if it's in aqueous solution, it's going to be electrolyte. Sodium chloride, if it's liquid, it would be electrolyte, but if it's solid, it's not electrolyte. Sugar, because it's molecular compound, is non-electrolyte because is not, it does not generate any ions. That's for the electrolytes. So know what are the 2 conditions. And second, if you are given like 2, 3 compounds, be able to say if it's electrolyte or if it's not electrolyte. Your next experiment, the acid-base titration. For the acid-base titration, just understand the difference between endpoint of the reaction, okay, versus like equivalence point. What does color change means when you are doing titration? I'm not going to bring like calculation for the titration for you find the concentration, but just know the simple definitions like when you hear titration, what does it mean? You should remember burette, you should remember pipette, you should remember color change, and basically when you add enough base to neutralize the acid, the indicator would change color, and you call that like endpoint of the reaction. At endpoint of the reaction, or when the neutralization happens, when the solution is completely neutral, the number of moles of acid equals number of moles of base. So to make it easier for you and for me, all the questions are going to be multiple choice or true false. So you please do not guess the answer, but if you review it before the exam, when you see the choices, you would recall it. It's not a hard exam, but if you never studied the experiments and you didn't do the pre-lab assignments, or you did not do the data sheet by yourself, I just warning you, you have to spend more time to prepare for the exam. But if you did all the work during the semester, you did the pre-lab questions yourself and the data sheet yourself, and you submit them, and everything will be graded at least, 1 week before your exam. It will be all graded. So if you have any questions, you can send email to me regarding your papers or any grades. And if you did do the work before, you have much easier time just review, and you will do good on the exam. The questions are not hard, but they are coming from the experiments. Review all pre-lab questions and review the experiments, read the experiments. Try to have an idea, what was this experiment about? What did actually happen in that step? And you will do good. If you have, especially if you study, you will do perfect. The final exam grade does not determine pass or fail. You could fail the final exam, still pass the class, because it has very low percentage of the exam grade, final grade. But if you do good on the final exam, you are going to either keep the grade that you have now or improve the grade that you have before you take the final exam. So I always ask the students, make sure you take it serious, you study the exam, and you do well, and good luck to you on the final exam. I may not see you after the, today's, because during the final, unless there's a complication, you don't have to log into the Zoom, and we don't have class next week. If if I don't see you, I wish you all the best, and I hope that you enjoy the rest of the semester and your break.